I want to be able to draw on that. Testing 1, 2, is it recording me? Perfect. It is. I'm going to start just a second here. I'll make sure that I have the right project. Okay, I guess before we get started, has anybody worked on their design document at all, come up with an idea for their track? Yeah? Want to pitch it to the class? Give us an idea what you're working on? It's okay, you don't have to if you don't want to.
I just want to make it all a whole farmyard, that's why farm.
Okay, farm themed racetrack, lots of fun. I like
And
it.
if I get to animating, I'm gonna make it a chicken running around somewhere.
Okay. Sounds good. And did anybody get the chance to get in and play with the 3D modeling toolkit at all? In the past, I guess, when was our last class? Thursday, Friday, since Friday, over the weekend maybe? If not, that's okay. Although I do recommend you just kind of get in there and practice with it. If you leave it to the last minute, it's gonna be a lot to do, I guess. And it is coming up. It's, I guess, 9 days. If you need an extension, please let me know by Friday. That's the cutoff for requests for an extension, okay? It's the 31st is when the assignment is due. Okay. Let me just find, I forget which, here we go. Sorry, I was trying to find a sample project. I've got like 4, 1 for each section. Probably just condense it down to 1. Stick with that. Okay, today we're going to be covering the kind of an introduction to blueprints, which are Unreal's built-in programming language. If I can get this project open, seems to be open now. We'll share my screen just a second. So Unreal Engine's programming language is a visual scripting language. And what that means is that instead of writing out lines of code by hand, it uses a visual interface. In our case, it's a series of nodes. And each node, like so, represents a function. So we'll call this function f. And there will be pins that come out of it that you can connect to other functions, right? And the way that you read these graphs and the way that you string them together is from left to right. So when you're thinking of how the functions execute, which order they execute, this will be function 1, this will be function 2, so on, so on. And once this project loads up, I will show you an example of what I mean. Okay, here we go. Okay, so if you want to see an example of a blueprint that I've provided, you can go into the blueprints folder here in template underscore or template then blueprints. And here we can see a couple of different blueprints that I've provided. We'll just take a look at the cart as an example so you can get a sense of how to read blueprints and how they work. To open up a blueprint, you just double click on it. Right? And here you can see, I'll go to the event track. This is a function. I'll go to that in a second. Okay. On the left-hand side here, you can see graphs. And here you see this one called event graph. And events are these red nodes here, right? These red nodes with the little arrow and the little red output delegate. If you're familiar with any kind of, what do you call it, events and subscribers, this is a delegate here. We'll get into that probably next class, but here we have this event called event begin play. And if you hover over it, it'll tell you what this event does and when it triggers, right? I'm going to also share my screen before I forget so that people watching the recording can actually see what I'm doing. Okay. So event begin play, if you hover over it, event when play begins for this actor. So basically, when this actor, and an actor is just a, it's like the base class that everything inherits from in Unreal Engine. When this actor starts in the game, right? So whether we instantiate it after we've started running the game, whether we place it in the level and then we start running the game, this event is going to trigger. And what this does here is it adds a mapping context to the local input subsystem, which is a fancy way of saying, hey, this thing needs to listen for player input. So when we start the game, we start listening for player input. Now, if you're looking at a blueprint and you don't know what it does, that's because the blueprint is poorly made. We can add comments to this by selecting nodes and pressing C, and that will add a comment. And then I can say, listen for player input. But you can see we have this event that gets triggered. We have this white execution line that goes here and calls this function add mapping context. We have this event here, event tick. If we hover over it, we can see event called every frame. And a frame is just when the game updates the screen. So if you guys like movies, anything like that, videos, movies play in frames per second, so 24 frames per second. Every time the screen updates, this thing is called. Ideally, because if I come here, I click on these three lines and I say show FPS, frames per second. And I click on that. We can see that this is running at about 34, 35 FPS. This will be called 35 times a second. So ideally, you don't want to be putting really heavy computation on tick, right? If you put a function that takes 1 minute to resolve itself onto tick, your frame rate is going to crash and your game will not run. So only lightweight stuff goes on tick. And we can see this other one here. Again, it's provided by default. We're not using it. Event actor begin overlap. And this happens when this actor overlaps with another actor, right? If you ever are confused as to what an event does, just hover over it. Hello. And the tooltip will explain what it does. If you are still confused and you say event when play begins for this actor, what does that mean? Google it. And if you can't find a satisfactory answer on Google, message me. And down here, we have a few more of, again, of these type events, and these are input events, right? So you can see enhanced input action, IA accelerate. That's the event that gets triggered when I press the W key to accelerate. IA steer input action underscore steer gets triggered when I hold down either the A or the D key, and it tells it to turn. Right, so if we follow this pin, when this is triggered, we set our acceleration input value here. I'm not going to go too in depth as to like how this character controller works in detail, because there's a lot going on. You're welcome to kind of go in and explore on your own. So here, this is the event graph, right? Event begin play, you can see all of the events that are in our graph. We also have functions here. And these are accumulations of different nodes. All of these different functions. We have if statements. Everything you have in a programming language is all in here. Yes.
The overlap of it, feeling, talked about the player hits a wall, so like if you wanted to bounce back or something and happen upon hitting the object, essentially, is that what that one is?
Good question. Not exactly. So in physics, particularly in Unreal Engine, like let's say we have our cube here. If we hit it and bounce it off it like so, this is going to generate something called a hit event, right? Which is to say we've tried to go through this, we can't, and at this point of impact, it'll generate one of these events, right? And then whatever logic you have connected. Overlap is when this thing doesn't have, or like it has collision, but its collision is saying, no, 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 don't bounce off, pass through it, and it'll still call here, but it'll only call if we pass through. That's the gist. So in our case, for the player, like the car driving, it'll never really be called because we don't want anything to kind of like phase through our car.
Oh, could not be if you want to phase through the car, not the, okay, gotcha.
Right.
Yeah, yeah, yeah.
So if you want something to phase through, let's say, Mario Kart, you've got those little mystery boxes and you can drive through them. That would be an example of the car overlapping with another actor. Now, in order to keep our code separated and encapsulated, we would probably include all of the overlap logic on our pickup object if we were to create that rather than the car. Because if you have to include every single possible thing that the car can overlap with on the actual like car class, that class will become extremely bloated and very difficult to modify.
Can you make like a box to the finish line then, and that's a way of like tracking how many times you've gone around or something?
That is your second assignment. That is a yes. You can do the finish line. I would recommend a combination of a finish line and then checkpoints to make sure that they don't just like drive backwards and then go over it.
But it would be using something like that.
Yes. Okay. So we have functions and we have variables. So if you've ever programmed anything in your life, you are probably familiar with functions and variables. This has all of the same features and tools that a regular programming language has. However, it is just laid out a little bit differently. Okay, so this is one that I've created. But let's do a kind of hello world blueprint to get you guys started. I'm going to come out of the template folder here, and in the content folder, I'm going to right click and keep myself nice and clean and organized. And I'm going to create a new folder here. And I'm going to call this folder blueprints, because that's what we're making, blueprints. We're going to go into this folder. And again, I'm going to right click whenever you want to add something to your project, you right click on the content browser. And we're going to create a blueprint class. And if you hover over it, you'll see it provides a description. Blueprints are special assets that provide intuitive node-based interface that can be used to create new types of actors and script-level events, giving designers and gameplay programmers the tools to quickly create and iterate gameplay from within Unreal Engine without ever needing to write a line of code. I'm going to click on this, and you'll see that it's giving us this. And this is because this is essentially the parent class of our actor, right? It's saying, well, great, I want to create a blueprint. What kind of blueprint do we want to make? For 99.99999% of things, it's going to be an actor, right? And you can see a description. An actor is an object that can be placed or spawned in the world. If I click that, I'm going to call this BP underscore hello world. Okay, BP underscore hello world. Now you can see we have it in our project. We can double click on this and we can open it up. You can see by default, it shows us the viewports. And this is just in case you add any stuff that you want to see on your actor, like a 3D model, a text render, a material, whatever, it'll show in here. But we also have our event graph. Beautiful. These should be familiar. We just went over them. Begin play, actor begin overlap, and event tick. To add a function, you can right click, right? And you can see we have this big list of functions. Unfortunately, it does not provide any kind of guidance on what the commonly used functions are. These are just all of the functions in all of the different modules provided by Unreal Engine. And it can seem very overwhelming. The first function we're going to call is print string. Print string, right? And if you hover over it, it'll tell you what it does. Prints a string to the log and optionally to the screen. Voila. You'll occasionally see these little arrows at the bottom of your node. If you want to expand and see more information, you can do that. I'm going to expand it so we can see what this does. Print string. I'm going to drag off of the event begin play and into the print string. So we've now connected this function. When this actor begins, when it's created, when it starts in the game, we're going to call the print string function, and we should see a message printed on the screen. So we'll print it to the screen, yes. We'll print it to the log, yes. The color of the text will be light blue. It'll stay on screen for 2 seconds. And key, I'll get into that in a second. Right? I'm going to go back into perspective mode here. This is my janky level where I was just riffing around in 3D modeling. And I'm just going to open up my template level to keep things nice and easy. Oh, this is my soundtrack. Well, unless it wants to crash, that is also a possibility. Okay, here we have our sample track. You can play it. Okay. I'm going to click and drag this into the world. And you can see it's created that little icon. And that's just to show where it is, because right now we don't have any actual visible components on this blueprint. And you can see that it has all of the characteristics that you should be familiar with so far, particularly a transform. You can move it around. You can update its position, its rotation, and its scale. This is what makes it an actor, right? This is inherited from the base class of actor, is its transform, which gives it form, right? Because you cannot exist in the world if you do not occupy a position in space. I exist in the world because I am standing here. You all exist because you are where you are. That's what makes it an actor. And if I now press play, we have now printed hello to the screen for 2 seconds. Right, press play. Hello. That is how you use the begin play function. If I want to remove this connection, I'm going to come back in here. I'm going to move this onto tick to show you the difference. I'm going to hover over this white line, and you can see as I hover over it, it says exec. That's short for execution. That is the order in which functions are executed. I'm going to hold Alt, and I'm going to click, and it's going to delete that connection. And I'm just going to drag this down. I'm going to drag off of the tick event. I'm going to plug it into print string. The drag off of tick, plug it into print string. Our string says hello. I'm going to compile. So you have this thing up here, compile. You don't have to do this. If you run your game, it'll always automatically compile, but it's a good habit to get into because if you click on this, it'll tell you if there's any errors in your code. You can compile, you can save. Then if I press play again, hello, it's going to keep printing and printing and printing. It's going to print it 35, 33 times per second. That's how the tick event works. Okay. This is the basics of blueprinting. You right click, you pick a function, you connect it in here. Now, what if we don't want it to print hello? We want it to print something else. We could either go in here and manually write out some other message, but I would rather turn this into a variable so that we can edit what our hello world is going to say as we go. So to do that, we can click here and drag. And when you release, it'll pull up this menu. This is a really nice way of doing things because you can see this little thing here. It says context sensitive. When you do it this way, click out of in string, it's only going to show functions that actually provide this as an output, right? And I'm just going to go up to the top here at the menu. You can see it says promote to variable. I'm going to click on that. I'm going to call this message. And you can see on the left-hand side of the screen where we have our variables. Now we have this variable of type string of type, and it's called message. And if you compile, we can now set the default value of this variable. So I'm going to change this from hello to goodbye. I'm going to compile and I'll save. If I press play, now it says goodbye instead of hello. So just like any other programming language, you have variables. You set those variables, it will change how your function operates. Now, one thing I might like to do, like if I drag another one of my blueprints into the scene, maybe I want both of them to print, but I want them each to print different things, right? Right now, if I'm actually just going to move this onto begin play to make things a little bit easier to see. Again, hold Alt click to delete that connection to tick. Begin play. If I change this to now hello again, and I press play, you'll see they both say hello again, but I want one to say hello and the other one to say goodbye. How do we do this? Because just by changing the variable by default, it will change the default value for every single instance of this actor that we place into the world. So we're going to come to our variable here on the side. And when you have it selected, just like before, we have a details panel that shows all of the details, all of the things that we can do with this variable. We can make it here instance editable, whether this variable is publicly editable on instances of the blueprint. We're going to set that to true. And you can see there's this little eyeball here now that basically says, hey, this is now visible and publicly editable. I'm going to compile this. Now, you can see if with my thing, I'm going to go back to the world, I have one of my hello worlds selected. You can see now the message variable is exposed in our details panel. We can now go in and edit this. I'm going to tell this one to say goodbye. And I'll grab my other hello world. Tell this one to say just hello. Now, when I press play, one says hello, the other says goodbye. Now, when it comes to the order that these execute in, I'm actually not entirely sure how it determines which one goes first. I've been asked that question a couple of times in class, and I have gone down the rabbit hole of trying to figure out how Unreal Engine interprets the blueprints to determine which start function, which begin play should be called first. I don't know, it's anybody's guess. If you can find out an answer to that, kudos. Okay. We can do this with other variables as well. Right, so we can drag off of the text color, and you can see as I hover over it, it tells you the type of variable that it is. Right, it is a linear color structure, just a fancy way of saying it is a variable of type color. We're going to drag this out. We're going to promote it to a variable, text color. And again, if we want to edit this, we can either just click on this eyeball or click instance editable. We can drag off of here, promote to variable. And it's nice, it automatically names the variable based on the name of the parameter that you're dragging out to expose. And again, we'll make this instance editable. Now, if we compile and save, we'll go back to our world. I'll select my hello world 2. Now you can see all of these variables that we have exposed are now visible in the editor to change however we want. I'm going to make this text color orange, and I'll make it show on screen for 10 seconds. Now I'll press play. Now one is yellow, the other is orange, and it stays on longer. Okay. And you can see that we can do our hello world. We can do pretty much anything in Unreal Engine with very few exceptions with blueprints alone. You don't need to write a single line of code in this course. Okay. Any questions on what I've just shown you so far? I know a couple people came in a little late, maybe might need some catch up. Does everybody understand? I guess the main thing I want to convey to you is that this is a programming language. It works like every other programming language. You have functions and you have variables. The only difference is you're not writing out lines of code, you're dragging it onto a graph and hooking them together with wires. Okay. For those of you that came in late, to create a blueprint, you come into your content browser. I've created a file for my blueprints here. To do that, you right click and say new folder. And then to create a blueprint, you right click and create a blueprint class. It is going to prompt you to pick a type that you want, and you can see a description of what all of the different types do. Honestly, most of what you need to do in this class, like 99.999% of what you need to do in this class, actor will cover most of what you need. And this is just something that you can place in the scene, and it has a position, rotation, and scale in the world, right? And you can name it, I always prefix it with BP, blueprint for short, BP underscore my class, whatever you want to call it. I'm going to call this BP underscore spectator, right? And this is because maybe we want some spectators on the side of our track to cheer on our racer as they go on, right? Got our Hello World blueprint. That's all well and good. Let's try and make something a little bit more interesting, a little bit more complicated. I'm going to double click on my BP underscore spectator. And before I go into the event graph, because one thing I want to show you is if we press play, right now we can see these kind of little, I don't know, stickers, I think they're called. These little stickers that tell us where our Hello World blueprints are. If we press play, we can't actually see anything in the world, right? That's because the stickers are just to help us see where it is if there's nothing else to grab, right? So our spectators cannot just be, they're not ghosts, right? They can't just be invisible people sitting on the sideline doing whatever, right? That's no good. We want to be able to see the spectator. So let's go ahead and add a component. So in the viewport panel here, we have this thing here on the side that says components. Right now, we just have this default scene root. This is something that every single actor will start with by default. And it's just to give it a component as a root. I'm going to go ahead and I'm going to add, I believe, and can I add a cylinder? I can add a cylinder. I'm going to do that. And just like in our viewport, we can move this around. I'm going to scale this down a little bit to like 0.5, be about half the size. Then I'm going to add another one for a sphere. And you can see by default, it has made the sphere a child of the cylinder, right? So as you can see, just by the indentation, this sphere is a child of the cylinder. So if I move the cylinder, the sphere will move with it. But if I move the sphere, it will move independently of the cylinder. And again, I'm just going to scale this down. Now we have a spectator. Scale this in just a little bit more, just to give it more human proportions. There we go. Now we have our spectator. I'm going to hit compile and save. So we've created an actor and we've added two components. If you hover over, you'll see what kind of component it is, a static mesh component. So if you want to add a 3D model to your actor, you can add a static mesh component. Unreal Engine is very nice to us in the sense that if we just want to add very simple shapes for prototyping, it provides a whole bunch of simple shapes. Okay. And just like before, with any component selected, you can see all of the stuff you can do with that component here on the right-hand side in the details panel. Okay, so now if I drag this blueprint into the world, now we can see our spectator in the world. I'm going to press play. There he is. You can see him. I'm going to try and run into him, see what happens. You can see I kind of bounce off him. There we go. Now, maybe we want our spectator to have a little message hanging above their head, saying something, right? I believe we can add a text render component, right? Now, in terms of which components and how I know which ones to use, obviously I have a bit of an advantage because I'm familiar with Unreal Engine, but you can kind of just go through and try and find the ones that work best for you. Unfortunately, there's like a billion components and a lot of them you won't use. For example, like the heterogeneous volume component. and it's very helpful in telling us what it does, a component that represents a heterogeneous volume. There's a lot of this in Unreal Engine because there's a lot of kind of very niche modules that provide these things. And the documentation for these niche modules can be kind of hit and miss. But yeah, there's all kinds of different components that you can add. In terms of finding the right ones, look up tutorials and see what other people are doing, and they can provide a better sense of all of the different ones available. But Unreal Engine is very nice, and then it provides common components like audio, particle systems, lights. Scene components are just like a transform, it's a point in space. And skeletal meshes are used for animating characters. Static meshes are for 3D models that don't animate. And then we have a bunch of basic shapes. Most of what we do can be done with these common elements here. Okay, so I'm going to add my text render actor to add a message. I'm going to make it a child of the sphere because I want it to show up above the player's head. Oh, don't crash on me now, Unreal Engine, please. There we go. I'll just kind of scooch it above here. I'm going to change the alignment of the text. So with my text render actor, I don't like that it's kind of offset to the right. I'll change the alignment to be centered so that the text appears right above his head. So now if we press play, I'm going to close down these other blueprints, hopefully save a bit of performance here. Okay, now we have guy, and he has text above his head. And if we press play, we can now see he's got his text. It's kind of hard to read. We might want to make it bigger, change the color. Luckily, these are all things that we can do with blueprints by exposing them as variables. Okay. So unfortunately, these kinds of things here we see in the details panel, there's no easy way to just kind of click and drag them and expose them as variables. And that's because they're all kind of encapsulated inside of this component. But what we can see is in our variables tab here, I'm going to go over to my event graph where we can create all of our different logic. We have all of our components here that are exposed as variables. I'm going to drag my text render component into my graph. And it'll take a minute because for some reason it's running really slowly today. And you can see it'll open up this menu saying get text render and set text render. And that's because the two functions you can do to any variable, you can get them or you can set them. In our case, I'm just going to get it. I'm going to drag off of this, and you'll see it is context sensitive. I'm going to say set, and look at this. It goes to rendering components, text render. Because it's context sensitive, we can now see all of the settings that we can change on this component. So I'm going to click on set text. And just like before, we have this pin here. The little round pins are for variables, and the big white pins are for execution. We can drag off of this and promote it to a variable. Right now it's called value. That doesn't really tell us anything. There's an old joke. There's two problems in computer science, cache invalidation and naming things. Name things logically, right? Like if you're working on a blueprint and you're creating a variable, so help me God, if you name your variable variable1, I will lose my mind. We're going to call this, what do you call it? Dialogue, right? That's our text that we're showing. It's a dialogue. We know that we want it to be what this person is saying. We could call it spectator message. That would also work. Tells me what it does. Just name it in a way that clearly conveys what this variable does. And if we remember just from a moment ago, to edit this variable, we need to make it instance editable. Right? Now, if we come in here, and with our spectator selected, we now have our spectator message selected. We're going to change this to woohoo. I'm also going to come in here and increase the size of this text to like 100, just so it's a little bit more visible in game. And we'll change the color to red, just so it really stands out, make it a little darker against the horizon, like so. We'll compile, and we will save. Compiling, good habit to get into. It just tells us, hey, there's no errors, everything's working. Cool. And you can see it hasn't automatically updated, but when we press play, the begin play function will call, because we've begun playing the game, and we will set our text to woohoo, right? Any questions about what we've gone over so far? I know we kind of rushed through this. We only have an hour and a half. Has everybody managed to create a blueprint and hook up a function to the begin play or tick? Show of hands if you have not managed to do that, assuming you have a computer with you. Okay. This is something that in previous years, students have kind of struggled with, is grasping like a visual scripting language. Has anybody ever used a visual scripting language before? Seen one used? No. That's fine. I think you'll find in a lot of stuff, particularly like database development, web development, stuff where there isn't a whole lot of innovation going on. There's a big shift over to these kind of no-code frameworks. And the reason that a lot of companies and a lot of developers are moving over to these frameworks is because they don't have to pay somebody to learn to be a programmer. They can basically get the designer to just jump in and design, and then all of the, because what this will do is it'll actually like generate C++ code in the background. They can just have a computer generate all of the code based on the general design provided by the designer. Okay. So now we have our guy, and he has a message above his head. Maybe we want him to jump up and down, right? We want him to kind of bounce up, say his message. Okay. To do that, we're going to play a little bit with physics. So we're going to drag our cylinder. So this is kind of the base of our guy. So if we go to our viewport, we've got our cylinder here. This is the base of our guy. We're going to drag from here. We can either drag it from here in, or we can drag it from the components. Get, and we have our cylinder. We're going to come here. We're going to say add impulse. Add impulse. And if you hover over it, it tells you what it does. Add an impulse to a single rigid body, good for a one-time instant burst. And it is under the tab physics. So basically, what we're doing, we've got our guy. And we're just going to add some force upwards on him to make him jump up and down. Go ahead and add impulse. We can drag off of this pin. So the first thing we're going to do is we're going to set the text, and then we're going to make him jump up. And this will all happen in the same frame at the same time. And right now, the impulse vector, this is the magnitude and direction of the impulse to apply, is set to 0, 0, 0, which means it will not apply any force in any direction. If we wanted to apply force straight up, we're going to set Z here to 1, right? So in Unreal Engine, you have three vectors. You have X, Y, Z. Z is our up vector. And X and Y are your horizontal vectors. Okay, let's see what happens. I'm going to move my spectator a little bit closer to my player start so we can just see what's going on right away as opposed to having to drive up to him. I'm going to press play. You can see nothing has happened. When I exit, you can see it's provided me an error. This is why it didn't happen. VP spectator.cylinder, right? So this is where the generated code comes in. If you remember dot syntax, I think C# uses dot syntax, C++ does. Anything is like a property of this or property of cylinder. Cylinder has to have simulate physics enabled if you'd like to add impulse. So if you ever get a message, you can read this and you can say it has to have simulate physics. You could copy and paste this and Google it, but this is pretty self-explanatory. The cylinder has a setting, simulate physics, that needs to be turned on. Does anybody remember where to find the settings of something, right? All the possible settings when you have something selected, where do you find it? Right, select my cylinder. Where am I going to find the simulate physics button? Details panel, right? Select something, details panel, that's where all your settings are. I'm going to scroll through here. Okay, sockets, no. Static mesh, materials, no. Component tick, physics. And here we have our setting, simulate physics. I'm going to press Control S. Just to save. And then I'll compile. And we're good to go. Now if we run our game again, you can see he didn't really jump up, but we're not getting our error. So we're calling our function, I hope, but he's not jumping up. Maybe we need to apply more force. Exactly. Now, we could come in here and just set this to an arbitrary number. Look, if I set this to just like 10,000. Set this to 10,000. I think this guy's going to go into the stratosphere. Let's find out. If I press play, boom, he jumps up, right? It would be nice to be able to control how much force is applied and in which direction it is applied. Okay? We're going to be doing a bit of math in this course. Who here likes doing math? We have one person likes doing math, two people like doing math, and they're kind of on the fence about math. I hated math until I got into game development. And that's because math was always this kind of abstract, random thing that didn't do anything for me. If you don't like math, this will change your mind, because you will start to see the results of the math that you are doing, right? You know those problems you did in school, like Johnny has 10 watermelons? Well, now we actually have 10 watermelons in our game. We can do whatever we want. So the first thing I'm going to do is I'm going to drag off of this and turn it into a variable. I'm going to promote it to a variable, and I'm going to call this jump direction. And you can see by default, it says you need to compile the blueprint to change the default value. So we'll go up here and click compile. And now we have our jump direction. And we've set it to like 10,000. I want to multiply this by another variable. But we don't have anywhere to like drag off of to create this variable. We can just go to the variables tab here, and we have this little plus button here. I'm going to click plus. You see we've created this new variable, and I'm going to call this variable jump. Now, if I drag this in, and I try to drag off of this, and again, what do we need to do? We need to multiply it, so I can say multiply. Now we have this multiply node. If I try and drag this in, oh no, it doesn't want to let me multiply. It says Boolean is not compatible with vector, right? You cannot multiply a vector by a Boolean because a Boolean is just a true-false value. So we need to change this variable type from a Boolean to, has everybody here gone over the different types of variables that are just like generally available? What do you think we should change this variable to? We want to control how much force is applied. I want to hazard a guess. A double would work. Integer, less so. You can do it. It'll work with an integer. You just have a little bit less control. To change the variable type with our variable selected, once again, we go to the details panel to see all of the options for the thing we have selected. We click on this drop down where it says variable type. And here we have all of the common variable types. We have transforms, vectors, rotators, floating. A float would work. I believe we have doubles as well. They are not super commonly used. You'll see them a lot when you're doing C++. In blueprints, typically we just use a float, but a double would work as well. I'm just going to change it to a float. You'll see it'll start doing a check to basically being like, oh my God, you're changing this variable type. If we have a big blueprint and we've used this variable 1,000 times, it's going to run through and check. And you can see it's just searching. Is changing this variable type going to screw anything up? Is it going to break our game? Is it going to break our blueprint? And it'll say, no, the only time we use it is in this get jump force. And we can say, okay, cool, doesn't matter. I'm just going to drag it into here. And you can see this time it is compatible. And we are multiplying a vector, our jump direction, by a float. And when you do that, right, a vector is 3 values. So in our case, it's x, y, z. If we want to multiply this by a float, it is going to multiply each value by our float and generate x times f, x times f, or y times f, and z times f. It's just going to multiply each component of our vector by the float to generate our result. Okay. So in our case, our jump direction is 0, 0, 10 million. And our jump force will compile and we'll change it to, again, we'll say maybe 2,500 because like 10,000 was way too much. Right. And so if we do this math in our head, what's 0 times 2,500? 0. 0 times 2,500 is 0. 10,000 times 2,500, that's going to be way more, and he's already jumping way too high. So I'm going to change this default value to 1. And then we're going to plug this in to the impulse value, because you can see that the output of this is a vector. Unreal Engine is really nice about casting as well. So is everyone here familiar with the idea of casting, where you need to say, treat this variable as another variable of a specific type? Unreal Engine and Blueprints, if it can, will always automatically cast for you. It is super handy. It'll save you, well, I shouldn't say always. For simple variable types like this, for math, like vectors, floats, integers, strings, text, stuff like that, that's easily converted. It'll always do it automatically for you. When it comes to kind of bespoke stuff, like our BP Spectator, it will not automatically cast to, let's say, its parent class, which we can see up here in the corner. It won't automatically cast to actor, and it won't automatically cast to any child classes we make of this Spectator. Okay, I'm going to compile and save. Then we can run our blueprint. And he kind of does a little jump. Okay. If we wanted to be really safe here, oops, that's why I'm running so slow, I think. I'm running 2 instances of Unreal Engine. There we go. Okay. If we wanted to be really safe, we could come in here. We could take jump direction and jump force. I'm just going to click on these little eyeballs to expose them. And now we can see them here. But I have a problem when I expose something like this. I have a golden rule. A lot of what I've done in work is just like making interfaces like this to expose information that I want the user to have in a way that doesn't let the user screw things up. Because imagine you're working on a team and you give this blueprint to somebody and they come in and they were like, oh, okay, how does this work? I don't know. Okay, I'll set this to 1,000,000. So now we're doing 1,000 times 2,500. And our guy is now a rocket ship. He's gone. He's in orbit, right? It's a good idea to always limit human error where we can. I'm going to drag off of jump direction here. I'm going to normalize the vector. Normalizing, if you hover over it, returns a unit vector, which is just basically, if this thing is set to 10 million in the z-axis, it'll change it back to 1 in the z-axis. Not mandatory, but again, good habit to get into. And we'll click save, and now if we run it, our guy will jump normally. It would be nice, though, he kind of jumps once and then he stands there. It's a little boring. It's not very lively. It would be nice if he kind of bounced up and down. So once he jumped up, he came down. And once he hits the ground, we want him to jump up and down again, right? Let's see if we can do that. So we talked a little bit about the actor begin overlap. All of these components have their own events too. So I'm going to come to this cylinder. And I'm going to scroll down. Again, details panel, everything available. We have this events tab. And we have this event on component hit. So I'm going to click plus on this. And you can see it has created this on component hit event. If we hover over it, it'll say event is called when a component hits or is hit by something solid, like, for example, the ground. But it also provides a little bit more information. This could happen due to things like character movement, using the set location, any kind of physics simulation. So in our case, we're hoping to trigger this hit event when he hits the ground. Okay. And you can see this event generates a whole bunch of information about the thing that we hit. So we could just copy and paste this in Control-C, Control-V, and then hook it up here. And this will probably work. Let's see. Now, so he's not jumping up again. So I want to check to see if this event is triggering. There's a couple of ways we could do this. Unfortunately, the first way is a lot easier if you have other monitors. And this is where I'm going to try and do this. I'll drag this out like so. And we can press play. And you can see, right, if I press play again, I'll press stop and I'll press play. You can see if you have the blueprint tab open, it'll actually show the function being executed in real time as you simulate your game. So we can see that this begin play is calling, but this on component hit is not calling. That's an issue. Let's see if we can fix this. The first thing I'm going to do is I'm going to go to the cylinder. And I'm just going to go into its settings and see if there's anything related to hit. So I'm going to go into the search bar and select and just type in hit. Here we go. Simulation generates hit events. Right now it's set to false. Let's set that to true and see what happens. Now will he bounce up and down? Yeah, there we go. Not very good, but he seems to be having some kind of seizure. This is the process of development. Okay, we've solved one problem and it introduced another problem. Let's see if we can keep him from jumping up and down, or from rather rolling side to side. In the physics tab, we have this constraints, right? A constraint, to constrain something is to prevent it from doing something. And we can lock his rotation. And this, hopefully, we just say, okay, now you can't rotate. We'll keep him bouncing up and down, but we'll prevent him from rolling around like that. There we go. Now we've got a little spectator that can stand at the side of our track and will bounce up and down. Okay. So I'm just going to drag this guy to the side of the track. I'm going to rotate him around so he's facing the track. And then with him selected, I'm going to hold Alt and I'm going to move, release Alt, hold it again. So now we can just have a little audience standing here on the side of the track for our player. Beautiful. And I'm just going to back up and rotate around, and we can now see our little audience at the side of the track. Now, there is something a little weird. Audiences don't jump in unison, right? Like if ever you're going to a sporting event and you see everybody all jumping up and down in perfect unison, you're in a cult, okay? That's weird. It's not believable. You kind of want to avoid things. You can see that they're kind of breaking up their rhythm over time, but we would like to ensure that they kind of change things up a little bit so that they start jumping at different times so that they, right from the start, they kind of stagger their motion, right? I'm going to right click here. I'm going to type delay. And this allows us to add a delay. You can see this little clock here. And that tells us that this is a latent function. So this is a function that operates in real time, right? So what will happen is we'll set our text. We're going to delay. We want it to be a kind of random amount for each one. And then they will jump again. So we want a random float to go in here. If I drag off of this, I want a random float. I can just type in random. Here we go, random float in range. Let's just set a min and a max. That's probably what we want. I'm just going to set it delay between 0.5 seconds and 1 second, and then start jumping. And just to make sure that it's working, I'm going to add a print string on the end of here, just to say started jump. Now, we probably want, well, we'll just do this for now, and then I'll show you how to make more clear debug messages in a second. Right? And they all just kind of started their jump, and now you can see they're all a little bit staggered. I'm going to change this random amount to be a little bit wider, just so I can demonstrate nicer debug messages than this. Because started jump is all well and good, but which one of them has started jumping? We don't know. Any one of them could be calling this string, and it would be nice to know which one. I'm going to drag off of this. It's going to chug for a minute for me. I'm going to type in append, right? So this is, again, the same name as other coding languages will use. If you want to combine two strings together, you append them. Sometimes you'll hear the word or the term concatenate. Never know how to pronounce it. I believe we can also, if we type const, right, that's the other common name for append. Unreal Engine is smart enough to know. You can see in the description it says concatenates two strings together. I mean, in the second one, we know that we've just started to jump, but we need to get this actor's name. We want to get a reference to this actor within itself. If I type in this, we can see down here at the bottom, we say get reference to self. Unfortunately, this used to pull this up by default, but they've added this remove this constraint function to another library. And now because this is a better result for searching this is what comes up. You can also just type in self, get a reference to self. And we can drag off of this and get all of the properties that that we have, and we can say name, get object name, and we can plug that in to here. I'm going to press Control S, compile, and save. Right? One started jumping, the other started jumping, the other started jumping. But you can actually see, I'm going to rotate around, and we can see we've actually got a bit of a problem here. It's debugging 101. I rotated the face. They're all jumping, but I didn't tell them to start jumping yet. That's because it's detecting, probably calling this collision here, but let's make sure. We're going to add a print string. Collided. Press play. Right, you can see that they've all automatically collided. This is a problem for us, right? Because they start in contact with the landscape, they detect a collision, and then they start jumping. Now, so we're going to add in a Boolean. We're going to click a variable, and you can see it's defaulted to float because that's the last type of variable we made. I'm just going to call this lowercase b can jump. You don't have to prefix things with b for Booleans. I like doing it. It's a habit I've gotten into. Not mandatory. Can jump question mark, whatever. I'm going to get this value. I'm going to drag out of it. I'm going to type in if. And you can see it's taken us to this node here called a branch. I click on branch. And you can see this is just like an if statement. We have a true outcome and a false outcome. I'm going to drag out of my hit component into the branch. And if can jump is true, we're going to jump. And if it's false, we don't do anything. We can just leave it blank. And then what we need to do is when we add our impulse and when we start jumping, we need to set this to true, right? So we can get variables. I can say get, and we can drag out and set variables. You can also right click and just say set can jump. All of these variables show up in your context menu. So if you don't want to click and drag and say get set, you can just go set jump force. You can see variables under the tab default have all of these. Okay. Now our guys should stand still. And when they start jumping, this guy's taking a minute. There we go. And they will stagger their jumping. And this is what we got. Okay. Now, one thing I hate more than anything else is repeating code. Oh, it kills me. When you can send something into a function, you should do it. So I'm going to grab this add impulse because we have copied this to here. I'm going to click and drag and hold shift and click and drag to select all of these nodes that let us jump. I'm going to right click, and you can see under the organization tab here, we can collapse them to a function. I'm going to collapse to a function. And we should probably call this something other than new function. If I see a function in your guys' code called new function, fail, instant 0. Do not do that. It killed me every time. I'm just gonna call this jump. Because that's what we're doing. We're jumping. Cool, jump. Here we go. Then we can go in here. We can delete all this. And we can either drag this function out, and we can just grab it and do that, or we can right click, call function, jump. There we go. Now we have a function for our guy to jump. Control, file, and save. There we go. And it's all working. They all kind of go, hey, great, yay, cool. Jump, 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 jump. Nice. Okay, we have 10 minutes left. Are there any questions about what we've covered so far? I know we covered a lot. I know that the interface is definitely unfamiliar to you if you've never used a visual scripting language. It's a bit of a hurdle to get over. I get it. But the logic should all be familiar to you. Variables, functions, events even. Like most, any kind of framework that you're using is going to have some event for when the program launches, when you open up your website. And it's going to generate events that you can tie into. Sometimes they're called callbacks that you can tie into to add functionality to your game, right? That's the gist of it. We can expand this guy a little. I'm going to use the last 10 minutes to expand this guy a little bit further. I'm also going to get rid of this debug here because now we know that it's working. We don't really need the debug there. Less, okay. Here where we have our set text, we have our spectator message here. I'm just going to hold Alt and get rid of this. I'm going to select my spectator message variable. And here you can see it's set to type text. But we have this other drop down here. And you can say, make this variable a container, an array, a set, or a map of the contained type. I'm going to turn this into an array. And it's going to chug for a second because it's saying, oh no, you're changing a variable type. Again, anytime you do that, you risk breaking your game. This is a small variable. So we're going to do this. And we're going to compile and save. And you can say, oh no, now we don't have anything to go in here. When I compiled, it's now showing this little red error. We're calling set text, but we're not telling it what to set the text to. It's going to return a null reference. Our game is going to crash. Nobody's going to be happy. Okay. We're going to grab a random message out of this, right? I'm just going to add defaults. You can do that by clicking this plus. You can see now my array has 3 elements. I'm going to say, yay. Oh my God, caps lock, you're killing me. Yay. Go faster. There we go. And out of here, my array, when you want to get an element of an array, you can say get. Getting a reference basically means any changes you make to the thing that you get will propagate back to the array. Getting a copy means any changes you do won't propagate back to the array. We're just going to get a copy because we're not planning on changing anything. We're going to get the first one in here. And we're going to set our text. The first element in the array, which should be yay. Now they're all saying yay. Okay. And just like before, where we did a random float, here we have this integer that we're using to sample our array. We're going to drag out of here. We're going to say get, or rather random. Here we go. Random integer in range. 0 and, well, when you're just doing quick development, I know that this array is only 4 long, so the length of the array -1, we say 3, or we can grab our spectator message, copy and paste. Len, your function to get the length. subtract 1, random integer, right? And all I'm doing is I'm right clicking. If I want to do a math operation, just type in the math operation, add, multiply, divide, all of these, subtract 1, random integer in range. We're now going to get a random message. Yay, woohoo, claps. Now they're all getting random ones too. Okay. And if I wanted to be really clean, I could grab all of this, right click, collapse the function. We'll call this set random message text. If you wanted to be really clean, you could go in here. If you double click on the function, you can go in, you can see all of the nodes that we placed. You could even grab here and collapse this to a function. And I'll collapse function, and I'll say get random message. And you can see it has this blue execution node, but we don't actually need to execute. Here we have this option called pure. And we're going to change the output to message text. Now we have a function. We can compile and save. And we have our set random message text that we also want to call every time he lands, set random message text. Now we have a beautiful audience who will change the messages that they say as they jump. Okay. We'll go over more into like arrays and flow control, like getting and setting arrays and stuff next class. But what I really want you to take away is events, functions, variables, and nodes. Right click, search the node you want. Drag off of any of these pins, it'll give you relevant nodes that you can call based on those pins. I know it's a lot. If you go into the D2L for the module Introduction to Blueprints, there's like a couple of tutorials you can follow that are a good kind of overview of what we're doing. Next class, we'll go over some arrays and stuff, and we'll also go over collision volumes and get you started on your next assignment, which will be making sure that your player can track the number of laps that they've completed. Okay. With that, we've got 2 minutes left. You guys can take off if you'd like. I'm here for any questions for 2 minutes, but I do have another class I have to run to in 10 minutes or so. Okay. Thank you guys very much for showing up. Hope you learned a lot today. This is where it gets fun, guys. Trust me. It's where we actually start programming interesting things.